In this video, we're going to work on writing and naming ionic compounds. To start us off, we just want to remind you that an ionic compound forms between a cation and an anion being combined together. In middle school, you learned that this was a metal and a nonmetal, and now we have expanded your vocabulary to cation and anion. Cations are metals with a positive charge, and anions are nonmetals with a negative charge. So we have a set of rules when it comes to naming ionic compounds. You always name the cation first. If it's a metal, you're going to use the element's name as you find it on the periodic table. If it's a polyatomic ion, you're going to use the name that you find on the polyatomic ions list. And if it's a transition metal, you're going to use something called a Roman numeral. Now, Roman numerals are those symbols that we use to convey numbers in writing. The numbers that we have to convey for a transition metal is its ionic charge. Transition metals are the only type of element that can take on multiple charges, and therefore they need the Roman numerals to tell us which charge we're looking at. If we have a +1 charge, we will write a I for that. +2 will be a double I. +3 will be a triple I. And +4 will be an IV. These symbols must be included in the name if you have a transition metal. To name the second part of the compound, which is your anion, you're going to look at if it's a nonmetal or a polyatomic ion. If it's a nonmetal, you want to just change the ending to IDE. So something like sulfur would become sulfide. Something like oxygen would become oxide. Phosphorus would become phosphide. Bromine would become bromide, and fluorine would become fluoride. All of those are nonmetal elements found after the staircase on the periodic table, and they all end in IDE. Essentially, we know where to hack the original ending off at after the first syllable. So for instance, chlorine, syllable being chlor, becomes chloride. Sulfur becomes sulfide. We're going to do 3 questions on the front, and we're going to do 3 questions on the back, and then we're going to go over the review questions. The answer key for this document has been posted, so it is not expected to be turned in for a grade. However, you will be using this information, notes, and practice to help you prepare for the midterm and for the unit test. So if we have something like magnesium and nitrate coming together, we need to figure out what the drawing of that will look like, what the ion ratio and chemical formula for that would look like, and what the compound name would be from those combinations. So let's take care of magnesium. If I look up magnesium on the periodic table, then I can see that it is right here. It is an alkaline earth metal, and so it is going to have 2 valence electrons, just like every other element in this family. Because it has 2 valence electrons, it will lose those to get us a positive cation charge. That's like any element in the first family will give you a +1 charge. Transition metals are skipped because they could be multiple versions. Anything in boron's family will be +3. Carbon is the max, so it can be plus or -4. And then we hit our anions, our nonmetals. Nonmetals do not care about how many valence electrons to lose. Nonmetals care about how many valence electrons to gain. So if nitrogen has 5 valence electrons, it needs to gain 3 to become full, which means it's -3. Oxygen is -2, and any of the halogens are -1. If you have not wrote the ionic charge trend on your periodic table, please pause the video and do so now. Based on our ionic charge trend, we can see that magnesium is going to be a +2 charge. So the word magnesium looks like Mg +2 as a cation. The anion is nitrate. Nitrate is an element, is a compound that we want to memorize as a polyatomic ion. Anything that ends in ATE, ITE, or is called hydroxide is a polyatomic ion. When we go to our periodic table, polyatomic ions are going to be located on the back. So if anything ends in ATE or ITE, it will probably be on the back. We can see that this giant list of common ions is divided into cations versus anions. And then inside of that division, it is also listed alphabetically, meaning ABC order. So if I wanted to find nitrate really fast, it's in the anion column. So I'm going to look somewhere in here. And then I'm going to look for the N's. This is nitrate. Its formula is NO3 -1. So I'm going to write that in now. Once you know what your cation and anion look like as ions, you can draw them side by side so that you can compare them. We want to compare to see if they have the same total positive and total negatives when we draw them. My total positives is at 2. My total negatives is at 1. So we do not have balance right now. We have more positives than negatives. So I'm going to go ahead and add on another negative. When I do that, I can now see that I have 2 negatives to balance out our 2 positives, which means that everything is now the same number, which means it all goes away because it equals 0. Our ion ratio will be from the number of ions that we wrote down. So I wrote 1 Mg ion and 2 NO3 ions. I can use my ion ratio to determine the chemical formula that forms between magnesium and nitrate. Magnesium 1 becomes Mg1, and nitrate 2 becomes nitrate in parentheses and the 2 on the outside. One of the most common things that students mess up on is going to be that piece right there. When do we need parentheses and when do we not? We need parentheses when there is a polyatomic ion and when we need more than one of those ions. Now let's work on the naming part. So you're going to use your rules from the up above to help us name this. Well, what is our cation? What is magnesium? A regular metal, transition metal, or polyatomic ion? When we look it up on the periodic table, we can see that magnesium is an alkaline earth metal, which means that it is going to not need a transition metals Roman numerals. So we will name it as we see it, magnesium. Your anion is going to be a polyatomic ion, and that means that we never change anything about the name or formula of that ion except for the charge. So MgNO3 is known as magnesium nitrate. Let's do another example together. Let's do copper 2 and chlorine. Again, we're going to start by looking up the symbol for copper on the periodic table. What I notice about copper is that its symbol is Cu and that it is located in the transition metal family. So that means that the +2 that is with copper 2 must be its ionic charge. Remember, if it's a transition metal, it can have multiple charges. So the one that we're currently working with is just the +2. Now, chlorine is going to be an element that is a nonmetal found on the front. So we are going to be able to look up its ionic charge and symbol as chlorine -1. Now we want to draw these symbols beside each other and count up the total positives and negatives. We have 2 positives and we have 1 negative. We do not have a balance, so again, we will add until we are balanced. Now I can see that we have 2 positives and 2 negatives, which means that we now are balanced, and we can say goodbye to our ionic charges. We now again have a 1:2 ratio. Our Cu is 1 and our Cl is 2. Again, you do not always need parentheses. You only need parentheses when you need more than one polyatomic ion. Chlorine is a nonmetal on the front. Now we want to name this compound CuCl2 using our rules. Well, for our first part, copper, we will write its elemental name, and then because it is a transition metal, we will write in a copper 2. This is because the charge on copper was +2. For the second part, chlorine will become chloride. Any nonmetal on the front will change its ending to IDE. Now, last but certainly not least, for the one on the front, we are going to take care of aluminum and sulfur. So pause the video now if you want to try this one on your own. Since it is our last one, you should be able to do this one. But if you need some help, let's let the video play. So aluminum is going to be an element on the front. We can see it right here. So it will come with a +3 charge. Sulfur does not end in ATE or ITE, so that means that, again, sulfur will come from the front, and it does as a nonmetal. So we will transform that into S with its ionic charge -2. We're going to draw one ion each, side by side, and then we're going to check the total positives and total negatives. We'll have 3 positives and 2 negatives. So I'm going to add another negative, exactly how it's written. When I do that, I have 2 + 2, which means I now have 4 negatives and only 3 positives. So we'll go in and add another positive then, exactly how it's written. Now we have +3 and +3, so that's going to give us a total of 6. And we have S -2, S -2, so that's going to give us a total of -6. And we're going to have a total of 2, 2, 2, -6, 3 + 3, +6, and now we have balance. We have the same number of total positives as we do total negatives. This means that we now have a 2-to-3 ratio where we need 2 aluminums, we wrote it twice, to balance out 3 sulfurs because we wrote it 3 times. Now we can name it. Let's name the Al part. Well, if I look up aluminum's location on the periodic table, it is a regular element. It is not part of the transition metal family, so we will name it as aluminum. No Roman numerals. For our S part, that is sulfur. As we can see, one second, let me get this paused and pulled back up. Alrighty, if we look up sulfur's location on the periodic table, we can see that sulfur is a nonmetal, so it is going to need a name change to IDE. This becomes sulfide. So now that takes care of our examples on the front. Let's go to the back. So the back is going to be very, very similar, but we are going to see a couple of key changes. And so I want to do the first 3 rows together with you. When you're given a chemical formula, I can very quickly ask you to name it. And so if that is your task, here is what I want you to do. First, I want you to write your chemical formula on a piece of paper, and then I want you to split it between the first 2 capital letters. This means that your cation, the first thing listed is Mg, and your anion, the second thing listed is CO3. Now, this is not enough. We need ionic charges. So I'm going to go look up Mg on the periodic table. When I look it up, I see that Mg is right here, which means that I know its charge to be a +2. So I can change this to Mg +2. CO3 is going to be a group of atoms, and so groups of atoms are found on the back of the periodic table. So we're going to go ahead and flip to our common ion table. We're going to look up our CO3 in the C section, so that's going to be somewhere over here, and we can see that right here as carbonate. We're going to grab that ionic charge as -2 and write that in now. Once you know the drawing, you can check the total number of positive and negative charges. I have two positives, I have two negatives, and so that is very balanced. Those things are going to go goodbye, which means that we have a 1-to-1 ratio. Now we just need to name this compound. Mg is magnesium. Magnesium is a alkaline earth metal, so we do not need a Roman numeral. CO3 is coming from the back of your periodic table, so that makes it a polyatomic ion, and we do not change anything about the name of a polyatomic ion. So how we see it is how we write it. This turns out to be magnesium carbonate. Now, arguably, the most difficult type of compound to name is one that involves a transition metal or one that is adjacent to a transition metal, and that is what we have here. We have TiS2. If we wrote this down on our piece of paper and we split it between the first two capital letters, we will have Ti and we will have S. We are not going to say it's S2 because that is what came out from the drawing and the ratio, so we don't know anything about it yet. All I want is the letters and the positive or negative number first. Well, Ti is our cation, but it's a transition metal. And because of that, we do not know what positive number it is yet. So we're going to look at the anion to help us out. S is our anion. S is one atom by itself, so that means that it is on the front. And we can see S right here in the same family as oxygen, carrying a -2 charge. Now we want to take these symbols and use our drawing and ion ratio to develop what this looks like. Well, what is our ion ratio to help us out with our drawing? Well, our ion ratio is 1-to-2. So I need to draw 1 Ti plus and 2 S minus 2s. I need to count them all up. And I see that I have -4. Well, I need to have a positive value to balance that out, meaning that I will have titanium +4. One more time. I'm going to take a chemical formula and split it between the first two capital letters. If my cation is a transition metal, I'm going to put the plus charge there, but I'm not going to put a number because I don't know. I'm going to rely on my anion and the drawing to determine the charge of the transition metal. The anion is S with a -2, and we had to draw it 2 times. That means that we have a total of -4. I need to balance that out with a positive value, and there only can be one in the formula. So that means that everything should be +4. So that is going to help us name this. Ti stands for titanium. It is a transition metal, so we need our IV representing the 4. And then we will name the S component. It is a nonmetal, so it will have an IUD ending, which becomes sulfide. Now go ahead and pause the video and see if you can name CuBr2. If you can't, no worries. Let's go ahead and take care of it. So you always write it down and split it between the first two capital letters. You only care about the letters. No small numbers that are with it unless it's a polyatomic ion. We're going to go look up these things on the periodic table. So Cu is going to be a transition metal. So all I know about Cu is that it is plus something because it is a Tm, a transition metal. Br is a halogen, which is always going to carry a -1 charge. So we can turn that into -1. Now, because Cu is a transition metal, we want to use our ions and we want to use our drawing to match our ionic ratio and our formula to see what's going on. Well, Br is -1, but there should be 2 of them because this is a 1-to-2 ratio. So I'll draw another one in. When I do that, I have 2 negatives. that need to be balanced out by a positive value. That positive value is 2. So now we're going to name this compound. Cu becomes copper. Our +2 charge becomes a 2 Roman numeral, and Br becomes bromide. Now go ahead and take some time to practice some other examples inside of this table before you move on. The final thing that we will discuss is your review questions. I am not writing anything on my screen, but we are going to discuss the questions, and you should write down what you hear. Can an ionic compound ever consist of a cation to cation or anion to anion combination? Explain. Ionic compounds cannot. So the answer is no. They cannot exist in that combination. Ionic compounds must be a cation-anion combination. If we have a cation-cation combination, that would be metallic. And if we had an anion to anion combination, that would be covalent. What is the charge for all of the elements in the following groups? In group 1, this is going to be our conversation from our periodic table. In group 1, everything should be a +1 charge. In group 2, everything should be +2. In group 15, everything should be -3. We now have nonmetals on the right side. And then anything from group 17, our halogens should be -1 as your answers for that question. Question 3, what do the Roman numerals represent in a name? They represent the ionic charge of a transition metal. They represent the Roman The Roman numerals represent the ionic charge in a transition metal. And number 4, when naming a binary compound, meaning one that does not have a polyatomic ion, no polyatomic ion, what ending do you use to represent the anion? So a nonmetal is always going to be changed to IDE. So that's going to take care of the notes and practice problems for this document. If you need additional practice, go ahead and start now. You can check your answers using the answer key that's posted online. If you need some further assistance, please get with any chemistry teacher to help you out.